Hi, welcome back. This is Math 0955. Today we want to do section 9.2 on compound inequalities. And the first thing we'll talk about is the intersection of sets. So you've probably seen Venn diagrams. I hope you have. Maybe not. If not, that's okay. Basically, we have some numbers in a bubble, like 5, 6, 7, 8. And then maybe you have another bubble and it has some of those numbers, maybe not all of them. Like this. So we're going to look at intersections and unions of these kind of bubbles. We'll call them sets instead of bubbles, but there's the idea. And first off, the intersection, those are the numbers that are in both kind of blobs or bubbles, or we call them sets, right? So the intersection of these two sets, say this blob over here is A, this blob over here is B. The intersection A intersect B, and it looks like a kind of like a staple, this upside down U. That's the intersection symbol. A intersect B is going to be 6 and 8. Okay, so on the right there, you'll see the problem written a little bit differently. Instead of having this visual picture, what we have are just some given sets. So instead of drawing a blob with 5, 6, 7, 8 in it, you just write these curly brackets and put 5, 6, 7, 8. And then we want to intersect that set with the set 6, 8, 9. And all it means is basically just to take the numbers that are in both sets. So 5 is not in both sets, 6 is, so that's in the intersection. 7 is not, and then 8 is. And then on the other one, 9 is not. Okay, so to be in the intersection, you have to be in both sets. So we have, in this case, 6, 8. Oops, they already give you the brackets. So I could just put 6, 8, and that should do it. Okay. Right, this one, 5, 6, 7, 8, 9, and 0, 2, 3. Neither has anything in common, right? There's no numbers that are in both. So when that happens, you'll just say the solution set, the intersection, is empty. There's nothing in it. This is a little bit weird. The intersection of, okay, so this is number 3. I'm sure I'll do it in class, but it's the intersection of this set that has 3 letters in it with the set that has nothing in it. So the symbol, this symbol is the null set, but it really just means kind of curly brackets where there's nothing inside of it. So like this. So there's nothing that's in both elements, basically, is what you're looking for. And so the intersection is just the empty set again. So that's a bit of a trick question, but it comes up. Okay, and now we want to apply this idea to inequalities. So you'll be given 2 inequalities, and you want to know what numbers are kind of in both sets. Okay, so to do these problems, I generally will draw 3 number lines, and okay, so here's number 4. So I have x greater than -5 and, which just means intersection, x greater than 7. So I'm going to draw a number line for -5 to infinity. So this is for x greater than -5. I don't include -5, but everything above it. Okay, and then I'm going to draw a number line for x greater than 7. So 7 would be over here somewhere. And then I don't include 7, but it's everything above it. And then the intersection of those 2 sets of numbers is just going to be the stuff that's in common to both. Okay, so for instance, this number and this number are both in the same set. So it's kind of like you take one and put it over top of the other and see where the overlay is, right? Where do they overlap is kind of the way you'll think of it. So in this case, it's going to be everything beyond 7. And then 7 is not included because 7 really is not in that second set, right? It's not included. It has the open parentheses, so it's not in the second number line, but it is on the first number line. It's definitely included there, but it's not on the second. So you can't include it, and you have to kind of use the open parentheses. So the intersection of those two sets will be the interval from 7 to infinity. Okay. So you're going to have to go through in the homework and do each individual number line. X greater than 7 is this guy. And then they want the intersection number line, so the interval that's common to both. And then finally, they want it written in interval notation. Okay. So if you do it the way I'm kind of introducing it, you'll have done all these tasks. I just like to do, okay. So let's look at another one. Here we have number 6. X less than 3, and then x greater than or equal to -4. Okay. So again, I like to do 3 number lines. I want you to do 3 number lines, like on tests. You know, here I'll usually just label the 2 numbers, -4 and 3, and you want to put them on all the number lines so they all line up. -4 and 3, -4 and 3. And then it's, for the first one, I'll do x less than 3. So it's everything less than 3, but not including 3. So it's everything in that direction, but not including it. So I use open parenthesis. X greater than or equal to -4. So this time I include -4, and then it's everything above it in the other direction. And then the overlap between those two will go from -4 to 3. Right? So that's definitely included. The only question is -4 included. Well, yeah, it's in both sets, right? It's x greater than or equal to -4. So when you see that bracket, it is included in that particular set. Okay, above it in the first set, -4 is definitely in below 3, so it's in that set. So it's both in both number lines. So you put a bracket there. But 3 is not included, right? In the first set, it's an open parenthesis, so it's not included. It is included in the second one, but not the first, so you don't include it here. And so we'll have the interval from -4 to 3, including -4, but not 3. Okay, so you just go over to my number line and put all that in. X greater than -4 is right here. Okay, yeah, so you have to hit three buttons to get this. Looks like D. And then the solution set, square bracket, -4 to 3, open parentheses. Okay. All right. Then the only thing is they start making it more and more complicated with your inequalities, so you got a bit of work to do before you can actually graph the thing, right? So number 10, I guess, 3x is greater than 7x minus 28, and then the other inequality, 8x greater than 4x plus 8. So in the first one, I'll move the 7x. -4x greater than -28. I need to divide both sides by -4. That will change the direction of the inequality. I'll have -7 there. Let's look at the other guy. Divide by 4. Okay. So we have 3 number lines now. I'm going to plot 2 and -7 on them. So -7 is over here somewhere. Put 2 over here. Put them all so they're lined up, so you can see the overlap between the 3 sets. Everything less than -7, but not including -7, right? So that's that. Everything greater than 2, but not including 2, is this. So in this case, there's no overlap, and that's just the empty set. Okay, so anyways, -7 What the heck? Don't give it to me. I must have screwed up something. Maybe it's positive 7. Oh yeah. So negative, that's supposed to divide by -4 there. That'd be positive 7. Well, that screws it up. Bloody. Sorry. Okay, so let me try that again. I'm dividing by -4, so this would be positive 7. So I'm going to put 2 here and then 7 here. It's going to change my answer probably as well. Let's see. So x less than 7 is going in this direction. And we don't include 7, so open parentheses. X greater than 2, yeah, that changes things. So now there is an overlap in between 2 and 7. We can't include 2 or 7. 2 is not included in the second interval. 7 is not included in the first interval, so we're just stuck with all the numbers in between 2 and 7. But anyways, D, check, yes, continue. 2 to infinity, check, yes, continue. The solution is the center. Well, that's not it. It's this one. Check. Yes. Continue. And then finally, an interval notation. 2 to 7. All right. A little harder because I got some fractions, but no big deal still. 2 times 3 minus x less than -5, and then over here x minus 1 over 5 less than or equal to -1. Okay, so that first inequality I'm going to simplify by distribution. Move the 6. And then finally divide by -2. It'll change the direction of the inequality. So 5.5. The other guy, you have to multiply both sides by 5. Okay, so 5 over 1 times x minus 1 over 5. The 5's will cancel, and you'll just have an x minus 1. -1 times 5 is -5. And then we're going to add 1. Okay, so let's go to our number lines. And put on -4 and then 5.5. Make sure they're all lined up. And greater than 5.5, but not including it, is everything in this direction. Less than -4, but including it, is all that stuff. And then this time there's no overlap. Okay. So anyways, the first guy, 5.5-ish to infinity. The second guy, -infinity to -4. And then the last guy, there's just nothing there, so you go with the one that doesn't have anything, any glue on it. And then the solution set's the empty set. Okay, so then it's just more of the same. Okay, so now we have the shorthand version of the inequality, this and inequality. And what you're going to do with those is add stuff to all 3 sides, basically. So it's like solving 3 equations at once, or 2 equations at once. So the first thing I want to do in this problem, number 14, is isolate x in the middle. So to do that, I'm going to add 1 to all 3 sides. Instead of just adding 1 to 2 sides, add it to all 3 sides. So I'll have -2 less than or equal to x less than 1. And that turns out to be it. Literally what this inequality says is that x is greater than or equal to -2 and x is less than 1. But we just smush it all together, and it's a little quicker to work with. Okay, so it's the same type of problem. It's an intersection problem, just like what we've been doing before. You need not draw all three number lines this time. You could just work with this inequality. And it says that basically it's everything in between 1 and -2, like this. And then you include -2, but you're not including -1. So it's just going to be -2 to 1, like that. So the solution set square bracket -2 to 1, open parentheses, interval notation. Okay. I made a mistake. 1 plus 1 is 2. Sorry, there it is. Sorry about that. Okay. Then they want the actual graph of the thing. So we already sort of did that. Okay, so this one is a little more complicated, but it's the same idea. 15, -4 less than 2x plus 2 less than or equal to 4. So first I'm going to isolate the variable term. So I have -6 less than 2x less than or equal to 2. And then isolate the variable, divide. So, this time we have to divide everything by 2. Okay. And then the interval is going to go from -3, but not including -3, all the way up to 1, including 1. Okay. So the interval, not including -3, but then all the way up to 1 with a bracket. They want the actual picture. And then, okay, so this is but more complicated, right? Got a fraction in there, don't overthink it. So first I'm going to add 14 to all three sides. So we got 3 less than or equal to 3x over 4. And then less than 12. And now to isolate x, I'm going to multiply all three sides by 4/3, the reciprocal of 3/4. Okay. So on the left, it'll be 12/3, which is just 4, less than or equal to. And the inside, the 4/3 times 3/4 is just 1x. And then 12 times 4/3, well, 3 goes in the 12 4 times, and 4 times 4 is 16. So we're going to end up with an interval notation, square bracket 4 to 16, open parentheses. Okay. Then the graph it, 4 to 16. Okay, and now we're on to unions. So with unions, the picture is kind of like, so before with the intersection, if you had two blobs, the intersection would be the overlap, right? So this is the intersection, and we have A and then B, so we would label that A intersect with the staple B. For union, you're basically just taking everything that's in either one of them, or in the intersection. So for union, if this is A and this is B, you just take everything together. Okay? So anything that's in A or in B. And we use the U symbol for that. That's a little easier to remember because union begins with the letter U. Okay? So for instance number 17, we have the sets 5, 6, 7, 8. And then we have the set 4, 6, 8. So the union is any number that's in either one of them, right? So it's in the first A, or it's in B, or it's in both. And you don't have to repeat numbers, right? So 4 is in the second one, so we include that. 6 is in both of them. We include that. We don't have to write it twice. Okay? We need a 5. The 5's in that first one. And they should be in numerical order. Okay? They don't have to be, but they should be. 5, so we have 6. And then 7 is in A, so we include that. And then 8 is in both of them, so we include that. Okay. So it's basically, if it's in one or the other, you include it. Or if it's in both, you include it. Okay, so 4, 5, 6, 7, 8. So again, another one of these, just everything goes. The 1 is in A, 2 is in B, 3 is in A, 4 is in A, 5 is in B, 6 is in B, 7 is in A, 8 is in A, and then 9 is in B. And then there's one of the trick ones. So number 19, we have A, F, K, R, S, union with the empty set. Sometimes maybe more intuitive to think of it just as the set that has nothing in it. So the union, you have A in the first one, F in the first one, K in the first one, R in the first one, and then there's nothing in the other one, so you don't put anything more in there, and then that's it. Okay, so it's just A, F, K, R. Oh, I missed the S. So there's actually an S. I couldn't see it. It's because my handwriting is so bad. All right, so now you need to put an S in there. Are you in there? R. Make sure you put comma, not a period. Okay, great. So now we're into the interval problems. So you just think of the interval as kind of a set of numbers. And instead of looking for the overlap, you're basically kind of putting one on the other, and if it's in one or the other, you include it. So it's more like everything goes, kind of. So let's take a look here. Okay, so it's 20. We have x greater than 5 or x greater than 2. Okay, so do my number lines just like before. I'm going to plot each one. So I have 2 and 5. I just plot those numbers on my number line. So it's everything greater than 5, but not including 5. And then everything greater than 2, but not including 2. Okay, so the result, you can kind of think of it as the shadow of all of that, right? So you imagine there's a huge sun up here, raining sunlight below it. And so the shadow of the sun is just going to be everything above 2. But basically, if it's in the first one, like everything 2 all the way up to 5 is in the first one, and including 5. And then from the second one, all right, everything past 5 is in the second one, and everything past 5 is in the first one and in the second one. It's like you have to include that junk too. But it really is, you can think of it as the shadow of those first 2 number lines onto the third. Whoops, I didn't really answer the question, but I guess we did. All right, so x greater than 5 is A. X less than 2. Oh, x greater than 2 is D. And then the overlap of these two, I mean the sort of the shadow of those two is C. 2 to infinity. And then you just do your interval notation. So we're going 2 to \inf. Okay. All right. Let's get another one. So number 22. I have x less than 5 or x greater than or equal to -2. Okay, so I'm going to label those 2 numbers in order. X less than 5 is everything below 5, but not including 5, so open parentheses. And then greater than or equal to -2 is just everything above -2. And then if you think of the shadow, pretty much everything is going to be in the shadow, right? So the resulting shadow is just everything. on the left, that first number line causes a shadow. On the right, the second number line causes a shadow. And in between, both of them are causing a shadow. Okay. So that will be the interval from negative infinity to infinity, which is all real numbers at the end of the day. But anyways, kind of going through the motions over here with what they want. We will plot both. And then it's everything. Everything goes. That's our A. And of course, to put that in interval notation, it's negative backslash inf, comma, backslash inf. Always use parentheses with infinity symbols. And yay. Okay. Let's try 23. So x greater than or equal to 6 or x less than negative 7. Okay, so get our number lines. Here's negative 7, here's 6. Greater than or equal to negative 7 is all this, or sorry, greater than or equal to 6 is everything above 6, and also including 6. Then everything less than negative 7, open parentheses there, but then everything less than that. And then the shadow of this time there's nothing in between, right? It's just all this stuff on the sides is being shadowed out. So all of this stuff, but not including negative 7, there's kind of a hole there. And then everything beyond 6, and this time it is including 6. The shadow of 6 is on that third number line. To write up this set, the solution set, is a little more complicated. We'll have to go from negative infinity to negative 7. And then for the whole, we're going to put this union symbol, okay, this U. Okay, so negative infinity to negative 7 union with the set from 6 to infinity. Okay, so it's a little weird. You have to use the little button on the, I don't know the shorthand typing version of that, but let's put it in, right? So 6 to infinity, including 6. Negative, everything less than negative 7. Whoops, hold on. That's D. And then the compound inequality is the one with the hole in it there. Okay. And then to put it in interval notation, I go parentheses negative backslash inf, comma, negative 7, parentheses. And then for the union symbol, it's below it. Okay, so this time I hit the button. If you hover over it, it's just backslash cap. But, oh, sorry, it's backslash union. No, it's backslash cup. Okay, so you can type it in that way, but you just click on that. I don't have them all memorized. Thank you, computer. Then backslash, okay, so union, and then backslash 6 to backslash inf, or bracket, sorry, bracket 6 to infinity, and then open parentheses. Hold on. Okay, great. Then they just start making it harder again by giving you more and more complicated inequalities, which you have to turn around and solve them. No big deal. Let's do at least one of them, right? So 27, we have the inequality negative 3x plus 3 greater than 6, or negative 2x plus 12 greater than 4x. And so we just solve each. So I'm going to move the 3 over. Negative 3x greater than 3. Divide both sides by negative 3. That will change the direction of the inequality. Then over here, I'm going to move the 12. So get negative 2x greater than 4x minus 12. And then move the 4x. So get negative 6x greater than negative 12. And then divide by negative 6. If you divide or multiply by a negative, it changes the direction of the inequality. And so we have x less than 2. So go to my number lines now. (-1 to 2, (-1 to 2, (-1 to 2). Less than (-1) is everything this way. Don't include 1, so open parentheses on that. Less than 2 is then everything in this direction. Whoops, I drew it on the same number line. I mean to do that. Okay, so the second one, everything less than 2. So it looks like it's going to be everything less than 2, right? So from the second number line, you get everything less than 2, and then also less than (-1, but that's in the set everything less than 2. So it's just the set from (-infinity to 2 is kind of the shadow of the sun in that case, right? The only hole is to the right of 2. So at the end, we have (-infinity to 2. Okay, so (-1 to infinity is A. (-infinity to 2 is A. And then finally, (-infinity to 2 is the solution set. And then they want it in interval notation. Negative \inf to 2 parentheses check. Yay. Okay, now they're pushing you for some functional notations. Let's try 28. F of x is 2x plus 3, and then g of x is 3x minus 1. They want to know the x values for which f of x is greater than or equal to 5, and then g of x is greater than 20. So it's an intersection problem. So first I'm plugging in 2x plus 3 for f of x. So basically I just took this and plopped them in there. And then for the other guy, you're taking the 3x minus 1 and putting them in for g of x. 3x minus 1 needs to be greater than 20. So you solve each of those. And then you do your number lines. And this time we're looking for overlap, not shadow. Here's 1, here's 7. Greater than or equal to 1 is like that. And then greater than 7 is like that. And then the overlap is going from 7 to infinity. So 7 to infinity like that. So parentheses 7 \inf, and always parentheses with the infinity symbols. Another one. That one's an OR. And then we're into story problems. So problem 30, the bar graph shows percentage of countries, households with interfaith marriages in 1988 and 2012. Also shows percentage of households in which one person of faith is married to somebody of no religion. We have a formula here for the interfaith marriages, 1/4 x plus 27. I for interfaith marriage. And then x for the number of years after 1988. And then we have the households where somebody of faith is married to somebody who is non-religious. That is given by the formula 1/4 x plus 5. So n would be, I'm just going to abbreviate, no religion. But it's really a mixed kind of thing. And then x, again, is a number of years after 88. Okay. So part A, in which years will more than 41% of the country's households have an interfaith marriage? Okay, so you take interfaith and go 1/4 x plus 27. And it needs to be more than, not greater than or equal to, but just greater than. So we can move the 27 over. So you like 14. Oops, that's upside down. 41 minus 27. 27, 8, 9, 10, 11. So yeah, 14. And then multiply both sides by 4. So x will be greater than 6 carry the 1, 56. So add 56 here. 8, 9, 10, 11, 12, 14. 9 plus 5 is 14. 0. So after the year 2044, 41% will have this interfaith marriage. Or, yeah, it's weird. 2000, more than 41% of the households will have an interfaith marriage in years after 2044. So exactly in 2044, it may equal 41%. They want beyond that, right? So now they go to the interfaith version, or sorry, the no faith version, and ask the same kind of question, but with 16% instead of 41%. So you go and take the n formula, 1/4 x plus 5, and we want to know when that's going to be more than 16. Okay. So I'm going to move the 5 over. I have 1/4 x greater than 11. Multiply both sides by 4. So x greater than 44, and figure out when that is. So add 44 to 88. 8, 9, 10, 11, 12, carry the 1. 9 plus 4 is 3, carry the 1, 0, 1. So after the year 2032. This is the and version of the problem then. So now we have these two inequalities, and we want to find the intersection of them. Okay. So the two inequalities, x greater than 56 and x greater than 44. Okay. So right, so you can do number lines if you want to, or if you can kind of do it in your head at this point, that's fine as well. But I'm going to do number lines. Okay, so 44 and 56. So it says part C, based on your answers to part A and part B, in which years will more than 41% of the households have an interfaith marriage, and, so there's that word and, which means intersection now for us, more than 16% have faith and no faith marriages. So independently, we kind of figured those out, and now we want the intersection of those two intervals. So greater than 56 is all this junk. Greater than 44 is all this junk, and it means if I was put one on top of the other, where would the overlap be? So that is from 56 on. That represents the year 2044. Okay, so we'll go 2044. Okay. And then part D, based on your answers to part A and B, in which years will more than 41% of the households have an interfaith marriage, or more than 16% have a faith, no faith situation. So in that case, you're doing an or. So it's x greater than 56 or x greater than 44. Okay. And it's almost the same. The first two number lines are the same, obviously, and then you have the shadow that you're looking for. Okay, so greater than 44 is all this junk. greater than 56 is all this junk. And then the shadow of all that is just from 44 on. Okay, so 44 represents the year 2032. And that'll do it. Oh, and then this one's converting temperature from, so it's going to be a compound inequality for this one. So 31, the formula for converting Celsius to Fahrenheit, F is F equals 9/5 C plus 32. If the Fahrenheit temperatures range from 50 to 68 inclusive, what is the range for the Celsius? Okay, so what it's saying is that the temperature ranges are from 50 to 68 inclusive. So the Fahrenheit value is in between greater than or equal to 50, that's that word inclusive, and less than or equal to 68. Okay. What we want to do is convert this inequality into Celsius. Okay, so we have C in the middle. So how do I do that? Well, we have a formula for F in terms of C, 9/5 C plus 32. So what I'm going to do is replace F with this expression. I'm going to just stuff that expression in for F. So I'll have 50 less than or equal to 9/5 C plus 32, and that'll be less than or equal to 68. Okay, and then I'm going to solve for C. So I'm going to minus 32 from all three sides. So this will be 18, less than or equal to 9/5 C, less than or equal to 36. And then I'm going to multiply all three sides by the reciprocal of 9/5, which is 5/9. 9 goes in the 18 two times, 5 times 2 is 10. C less than or equal to 9 goes in the 36 4 times, 4 times 5 is 20. So in interval notation, that's going to be including 10, so square bracket 10, and then all the way up to 20, square bracket. So the only one with square brackets on both ends in the answers is B, so it must be that 10 and then 20. Check answer. Oh, and that seems like all of them. Okay, very good. As usual, I hope this helps a little, and I'll see you next time.